Hey guys, Mr. Middleton here, starting our fifth unit, similarity chapter. We're going to start out talking about ratios and proportions. At the end of this video, you should be able to understand the difference between a ratio and a proportion. You should be able to use properties of proportions to rearrange proportions, and you should be able to set up and solve proportions. Let's start with a little bit of vocab. Another name for a ratio is a fraction. Okay, so you've definitely been introduced before. You can think of a ratio as a fraction. That's a nice, easy way to think about it. And a proportion is just a statement of fractions that are equal, or ratios that are equal. Okay, we'll deal with this a lot in similarity. As far as similarity goes, when two things are similar, it basically means they have the same shape but not the same size. You can think of models or pictures or things like that. And so being in proportion or having equal ratios is really important. So just looking down here, when we look at A over B, this is a ratio. Okay. C over D is also a ratio. These both are ratios. Okay. But when we say A over B is equal to C over D, now this is a proportion. Write that all over everything. Okay, so when we set two ratios equal to each other, then that's a proportion. Try to get everything set. Okay, so now we're going to talk about the different properties of proportions, and this will come into play later as we talk about proving triangle similar. And you might not notice it then, but we'll see why it works now. Okay, so first we're going to start with the understanding that A over B equals C over D. Okay, and I always like to think of other numbers that this rings true. 1 over 2 equals 4 over 8. Okay, so if that helps you out for right now, you can, when I'm saying too many letters, you can look back and say, okay, does this work with the numbers? And you'll see that it does. Okay, and our first property is probably the most relevant or familiar one for you. If A over B equals C over D, then we know that A times D equals B times C. And this is just a property of cross multiplication. Okay, and you guys know that when you're solving fractions, that's usually, proportions. Cross multiply is the step that you guys heard the most. So cross multiplication works. If the ratios are equal, cross multiplication will work out. Okay. Also, if A over B equals C over D, then we can say that B over A equals D over C. Okay, and this is just the property or the reciprocal property. Reciprocal. Okay. A couple other things that work out for us. Again, if A over B equals C over D, then I know that A over C will equal B over D, saying that the ratio of the numerators should equal the ratio of the denominators. And finally, I should be able to say that A plus B over B equals C plus D over D. And this one seems the strangest, I think. Like, you might not think that you'll use it, but we will use it in this chapter. But I want you to notice that B over B is just 1. D over D is just 1. So basically we're saying if A over B equals C over D, if we add 1 to both sides, they're still equal to each other. Okay. Okay. So again, if you're like, wait, does that work out? Try it with these numbers. You know that 1/2 equals 4/8. Try it with these numbers. You'll see that all those work out. 2 over 1 equals 8 over 4. 1 over 4 equals 2 over 8. Okay, so if you need to do that, that works with all proportions that are equal. all proportions. So here we go. Now we're just going to be able to kind of practice this in a different way.
Zoe Hoffelmeyer, please come to the Freshman Academy, door 26. Zoe Hoffelmeyer.
So now we're just going to be able to practice this in a different way, and we'll see some of the properties happen. So, given a statement on the left side, we're going to make sure it equals whatever needs to go on the right side. So A times B. Well, we see that's cross multiplying here, so we're going to cross multiply on the right side. That's going to be 4 times 12, or 48. We'd write 48 because we can simplify that. B over 12 should be the same as 4 over A. A over 12 should be the same as 4 over B. Okay. Pretty simple there. Flipping to the back side. Okay, now we're going to have some proportions where we actually have to solve for variable, the value of a variable. Like I said, when you see proportions, naturally, hopefully, at this point, one of your first inclinations is to cross multiply. And that helps us out a lot. Gets rid of the fractions, makes it a little easier problem, or at least look like an easier problem for us. So that's what we're going to do here. We're going to cross multiply. Got 8y equals 4 times y plus 3. You'll notice I put parentheses around the y plus 3, and that's just a reminder that I need to multiply both things by 4, not just the y. 4y plus 12 equals 8y. I'll subtract 4y from both sides. And then I get 4y equals 12. And I'll solve for y. And that will give me 3. Oops. Y equals 3. Okay. So just use the cross multiplication to solve the proportion. Okay. When we do that, we could come out with some different types of numbers. So we'll look at some I guess later in algebra, still algebraic problems. A little bit of algebra review here. So in this next example, we have x over 6 equals 3 over 2x. X over 6 equals 3 over 2x. Solving this proportion, again, I'm going to start off by cross multiplying. So 6 times 3, 18. X times 2x, that is 2 times x, or 2x squared. Okay, and I want to get x by itself. So, I'm going to divide by 2, both sides. Gives me 9. 2, that's x squared. And so now I have x squared equals 9. Now, to find x by itself, I'm going to take the square root of both sides. And when I do that, I get 3, but I also get negative 3. So I'm going to say plus or minus 3. Okay, as we're solving these things, make sure that you take into account the negative root. If we're applying it to a length of a segment, then the negative number won't work. But if we're just solving for a proportion, the negative number is a solution. Okay. All right, and then just a reminder, we can always plug these back in and make sure that it works out, that it makes the proportion true. So if we did this for the first problem, 3 plus 3, that's 6. 6 over 8. Is 6 over 8 the same as 3 over 4? Yes, they're both 0.75 if you type them into your calculator and got a decimal. Okay, same here. If we put 3 over 6, is that the same as 3 over 6? Gets the same number. Yes. If we put negative 3 over 6, is that going to be the same as 3 over negative 6? And you see that it is. It's the same thing. Okay, they're both negative 1/2. Okay, so when we plug these in, they should make it true. All right, this last problem is a review of quadratics. Okay, again, proportion. We're going to start by cross multiplying. When I do that, I get x minus 3 times x minus 2 equals 7 times 2, which is 14. Okay, so a couple things we have to do here. Remember foiling or multiplying binomials. X times x is x squared. X times negative 2, which is minus 2x. Negative 3 times x, which is negative 3x. Negative 3 times negative 2, which is positive 6, equals 14. I will combine my like terms here. When I combine these two, oops, that is a plus 3. Okay, that will change this to make it a positive 3x. Positive times negative will be negative 6. Okay. Okay, so I'm going to add my like terms together. I have x squared minus 2x plus 3x gives me a positive x minus 6 equals 14. Now, if you remember your quadratics, remember the way that we solve them is we make sure that they equal 0 first. We cannot solve it with, well, unless we're completing the square, which we will not do right now. We want it to equal 0. So I'm going to subtract 14 from both sides. That gives me x squared plus x minus 20 equals 0. Okay, and so I'm trying to break this down or rewrite this problem in a way that I can factor it out. Quick review of how I factor. If you have a different way you can do that, I'm sure you can find other ways to review this. I always use the Xbox method, and I call it the Xbox method because I use an X and then I put it in a box. But the Xbox method, I want to find two numbers that multiply to give me a times c. Okay, in this case, a is 1. So negative 20. And add to give me b. Okay, and so we see that b is the number in front of x. That's 1. So I need two numbers that multiply to give me negative 20 and add to give me 1. Those two numbers are going to be positive 5 and negative 4. I'm going to put those in these two boxes. 5x, negative 4x, x squared minus 20. And notice in these last two boxes I have the first term in the first box, the last term in the last box. And basically I just go through each row and each column and I factor out the GCF. So what goes into both these things? Well, x goes into both here, 5 goes into both here, x goes into both here. I'll say negative 4 goes into both here. I see that they're negative because they're both negative. Okay, and then I just go through to make sure that when I multiply, I get all the same signs and right numbers. Negative 20, positive 5x, x squared, negative 4x. Okay, and so now what I have is I factored this down, and I'm going to rewrite it as x plus 5, x minus 4 equals 0. And from here we have to follow the zero product property. I'm going to continue up here as we're getting closer to our answer. Zero product property says that if we're multiplying two numbers and the answer is 0, then at least one of those two numbers is 0. So we're going to say, okay, we have two numbers, x plus 5 and x minus 4. If this one was 0, what would x have to be? Well, we set up our equation. If x plus 5 equals 0, then x would be negative 5. One answer. Okay. Again, if x plus 4 was 0, or sorry, x minus 4 was 0, I have to add 4 to both sides. And so that would make x 4. And that's our answer. All right. Last problem. Setting up a proportion given a word problem. So on a certain map, the scale is 3 inches equals 70 miles. If the distance from Fort Wayne to Indianapolis is 110 miles, how far is it on the map to the nearest tenth? Okay, so we're just asking how many inches is this on the map. Well, we're given a scale, and so that's our proportion. The scale is 3 inches is 70 miles. So 3 inches for 70 miles. Now, on our part, we know that from Fort Wayne to Indianapolis is 110 miles. So you'll notice the units on our first ratio is inches over miles. So in the ratio we're going to create, we're going to make sure that our miles is on the denominator as well. And that's 110. We don't know how many inches it is, so we're just going to say x. And now, solving this proportion just like we have, cross multiply. 70x equals 330. Divide both by 70. Take it up here so we can see it. I think. Sorry. 70 divided by 330. I did that wrong. 330 divided by 70, right? Okay, and that gives us 4.7 inches to the nearest 10th. So on the map, Indianapolis is 4.7 inches away from Fort Wayne. Okay, so that's proportions. And that will be very instrumental into this chapter over similarity. All right, see ya.